Hi there. So hopefully you watched my video from Module 1.3, sort of a general talk about transforming graphs. This video is to give you a little bit more information about those transformations and different things that we can do with graphs. There's some different rules that can really help you remember all of the movements, okay? So we kind of talked about these in that original video. When you're adding or subtracting, outside is the key word there. The parentheses, exponents, brackets, whatever they might be, moves the graph up or down. Adding or subtracting inside, keyword, moves the graph left or right. And remember that left and right are opposite. So left is plus, right is minus. When you're multiplying by a number larger than 1, it's going to stretch that graph out vertically. When you multiply by a number smaller than 1, the graph shrinks. And then, as always, multiplying by a negative will flip the graph over the axis. So let's write a rule for this transformation. Again, we're going to go red to blue. So red is the parent graph of f of x equals x squared. I need to write a rule for changing from red to blue. So I can see that I have moved that graph up. Now remember, when I'm writing a rule, I need to use a different letter to name my function. Most of the time we'll use G, okay? So we're gonna go from Frank to George. I'm gonna write G of x equals, and I know I'm gonna have an x squared there, and it doesn't look like I've moved left or right. It doesn't look like I'm stretching or shrinking. It looks like I have simply moved the graph up 4. So I'm going to say x squared plus 4. That's the graph for my transformation. Let's look at another one here. So this time red is the parent graph, and I'm given the function f of x equals 3 to the x power. I can clearly see that I have moved that over, okay? I'm looking at this point right here, and it looks that I have moved it over 1, 2, 3, 4, 5. How do you know which point to use, by the way? Does it matter? I mean, couldn't I also use, I'm going to do it in a different color here, this point right here to this point? Is it the same? 1, 2, 3, 4, 5. You want to pick a point on the graph that's easy to see, okay? I'm probably not going to pick this point right here because it's hard to count exactly over to see where it is. But both the purple and the green points are very clear on the graph and allow me to very clearly count the movement from red to blue. So in this case, I have moved my graph right 5, which means that my new function, g of x, is going to be 3 to the x. Now remember, the 5 goes in the parentheses or in the exponent with the x, and because I'm moving right, I do the opposite, which is minus 5. So I've written minus 5 for moving to the right 5 in the exponent of my function there. Look at this next one. The red is my parent graph of the absolute value of x. Now this hasn't moved, right? I still have the same vertex. So it hasn't moved up or down. It hasn't moved right or left. But what you can see is that it has stretched vertically and gotten skinnier. How about that? It's gotten skinnier so that it's stretched vertically. So how do I figure out what that's going to be? I know that a vertical stretch means that I'm multiplying by something in front of the parentheses. But how do I know what that is? The easiest thing to do, especially with absolute value, is count the slope, okay? So the original slope is up 1 over 1 for my function. The slope of my blue, I'm going to do this in a different color so that we can see it. How about blue? Is up 2 over 1. So if the slope of my first one, my red, is 1 over 1, and the slope of my blue is 2 over 1, what did I multiply that by? To stretch it, I multiplied it by 2. 2 is the multiplier that stretched my graph here. If I was going up 4 over 1, then 4 would be my multiplier. If I was going up 17 over 1, then 17 would be my multiplier. If I was going up 9 over 2, then 9 over 2 would be my multiplier. So it kind of just depends. Count the slope out and see what you've got, okay? And that's always true of absolute value. With other graphs, you can generally pick a couple points and count the slope, and then that helps you see, they're not quite as clear as absolute value, but that helps you see how they have changed. You can see here that red is the parent graph, and it looks like I have moved it down, the vertex down 2, okay? So I know that I'm going to have a -2 at the end of my function. But it kind of looks like maybe I've done something else to my graph, right? So it kind of looks like maybe my graph has gotten skinnier, don't you think? Where, let's see, so if I look at my red graph, I'm going up 2 over 2 to get the next clear points from the vertex. If I look at my blue graph, I'm going up 1, 2, 3, 4 and over 2 to get my next clear points. It looks like that has been stretched by 2. So not only do I have an x squared minus 2, but I need to multiply it by 2 as well. And that is my new function. So g of x is 2 times x squared and minus 2 because I moved it down 2. So sometimes we have more than one transformation on a graph, and that's okay. We need to just write a rule that describes all of them. I hope this is making sense for you to see how the graph is changing and write a rule. We try not to get into anything too complicated, but hopefully you can kind of see, especially the stretching and the shrinking of the graph, how that kind of works. You can see that the shape changes a little bit, and then you know that you're stretching it vertically. You can also see how the vertex is usually what you're looking at, moves up or down, left or right, and you can write a rule for that. Again, if you have any questions, please always let us know. You can send an email or you can find us and ask. We are more than happy to help. Hopefully this video clears up a little bit more about writing some rules to describe transformations of graphs. Have a wonderful day, and as always, have fun doing math.